Hello all. You are seeing this video because I am at home with my daughter who is sick with an ear infection, and my caretaker, Grammy, is also sick. So what you were asked to do in class today was, first of all, start by taking a practice quiz. About organic nomenclature, and then we are going to go over it, which is what this video is, and then I'll show you how I'll grade it, because Friday when we meet, you are going to take this quiz in real life, which will be similar format and different questions. So let's talk about the answers. Question number 1 says, in any structure, how many bonds or sticks should each carbon have? So the answer to that question is 4. Every carbon needs to have 4 bonds attached to it. Okay, so that's the big thing that we should always remember. The next one says, if all bonds are single bonds in a molecule containing 9 carbon atoms, how many hydrogen atoms are there? So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, and I do single bonds just like the problem asks for, and then I go and I start adding hydrogens. If I start adding my hydrogens here, once I start counting them up, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the correct answer here would be 20. And again, I tell you in the problem that you should draw if needed, and that certainly helped me, because I can't look at a structure like this and just know off the top of my head how many hydrogen atoms there are. I usually have to draw these things out myself. The next question says, what are the 3 suffixes for a hydrocarbon, and what do they tell you? The first one you should remember is -ane, and it tells you all single bonds are present in the structure. The second one is -ene, and that tells you all double bonds, or not all. Actually, that's not true at all. It tells you double bonds and I'm going to put S in parentheses, are present. So it could be more than one double bond, but in order for it to be an -ene, it has to at least have a double bond. And then the last type is -yne, Y-N-E, and that means triple bonds are present. And just like I said with double bonds, it doesn't have to be all triple bonds. It could be more. It could be one bond, or it could be one triple bond, or 2 triple bonds, but it doesn't have to be all. The other thing I want to talk about really quickly is how I would grade this. Okay, so question number 1 and 2 are going to be all right, excuse me, or all wrong, meaning it's 1 point each. Question number 3 would be a 2-point problem. So this is 1 point, this is 1 point, and this would be 2 points. Okay, so what that means is that you would get 1 point for correctly identifying ane, -ene, or -yne, and then 1 point for correctly telling me what those mean. All single bonds, double bonds are present, triple bonds are present, so on and so forth. So now, this next part asks you to identify or name the following hydrocarbons. And so I'm just going to kind of walk through how I do that again. The first thing I always do is I look for the longest continuous chain of carbons, which in this case is right here. I'm then going to go ahead and identify a couple of things about that. So the first thing I'm going to identify is that there are 1, 2, 3, 4, 5, 6 carbons long. So it's 6 carbons. And so that tells me the prefix has to be hex. I do see that there is a double bond. So I'm going to identify bond present. So there is a double bond present. So that means that the ending has to be -ene. Okay. And then the next thing I look for is branches. And in this case, there are none. So now I'm going to number my chain. And when I go to number my chain, I always number left to right, right to left. 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. Now, I'm going to number from right to left this time because I get to the double bond first. So that tells me that the double bond is between the second and the third carbon. So I'm going to just do that right there to remember, to remind myself. So when I go to write this, it's going to be 2-hex, and the ending is going to be ene. So 2-hexene. And so that's the name for the first one. The next one we're going to do is we are going to go also identify the longest continuous chain of carbons. So I'm going to do this. And you could have gone up, down, doesn't really matter. But that tells me that there are 1, 2, 3, 4, 5 carbons. So there's 5 carbons, which means it's a pent. And I do see that there is, in terms of bonds, there is a triple bond, which means the ending has to be YNE. I should remember that this is a double. Okay, so it's YNE. And then we're going to look for branches. Okay, and so branches, I've got this one right here, and it is a 1 carbon long branch. And so the prefix for 1 carbon long branch is a meth, and its ending has to be YL. Oops, that's not even, doesn't even make sense. It's YL. Like that, except we want it to be black because that was the scheme that we've been using. YL. There we go. Okay. So now I'm going to number my chain. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Now I'm going to go from left to right this time. And the reason why I'm going to go left to right this time is because I get to the multiple bond, the triple bond, before I get to anything else. Or I get to the triple bond first. When I number it this way, it's after the second carbon. If I number it the other way, it's after the third carbon. And even though the branch is on the second carbon, when I number it from right to left, the triple bond is always way more important than the branch. So when I go to name this, my branch is going to be on my 4th carbon, and the triple bond is going to be on the 2nd carbon. So when I draw this, it's going to be 4, or when I write this, it's going to be 4 methyl, and it's going to be 2 pent, and then the ending has to be YNE. All right. Moving along to question number 7. With question number 7, I'm going to first of all identify the longest continuous chain, and I'm just going to go straight across because to me that makes the most sense. I'm then going to go and identify how many carbons long this is, and it looks like it's a 3 carbon long chain, so that's prop. And there's the bonds are single. Which means the ending is ANE. Now we need to talk about branches. And in this case, there's a branch here and a branch here. Both of those are 1 carbon long branches, which means that that is a methyl branch. And then I'm going to number my chain. 1, 2, 3, or 1, 2, 3. And honestly, it doesn't matter which way I number my chain because I get to my branches first when I get to the 2nd carbon. So that means that it's a 2, 2. So that's going to be important in a minute. So when I write the name, it's going to be 2, 2 methyl. And then it's going to be a propane. So prop. And then the ending is going to be ane. Excuse me. Okay, so that's number 7. Number 8, we're going to go into and we're going to identify the longest continuous chain here. And I found it to be this, which just the way that I drew it or figured it out. It's 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Yep, it's a 6 carbon long chain. So that means it's going to be a hex. The bonds are all single. So that ending is going to be ANE. Now we need to look at branches. In this case, there's one here and there's one here. So there's 2 branches this time. There is a 1 carbon long branch, which is a methyl. And there is a 2 carbon long branch, which is an ethyl. Now off to numbering my chain. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. And it looks like if I number from left to right, I get to my first branch on the 2nd carbon, and if I number from right to left, I get to my first branch on my 4th carbon. So that means I have to number from left to right. So that will tell me that my methyl is on the 2nd carbon and my ethyl is on the, looks like, 3rd carbon. So when I go to write this, we have to put the branches in alphabetical order. So this is going to be a 3 ethyl, and it's going to be a 2 methyl, and the prefix is going to be, for the parent chain or the continuous chain, is a hex, and the ending, because it's all single bonds, is 8. So it's a 3 ethyl, 2 methyl, hexane. The next part that you were asked to do is to draw the structures. And so I'm just going to go ahead and dissect what the name tells me. ANE tells me all single bonds are present, and the prefix but tells me it's 4 carbons long. So when I go to draw this chain, it's going to be 1, 2, 3, 4, all single bonds. And then that's it. There's no branches. So now I have to add hydrogens until I get every carbon to have 4 things stuck to it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's number 9. Number 10, a little bit more complicated, but hopefully easier as we go through it. The ending is ANE, so it's all single bonds. There is a hept, so it's 7 carbons long. There is a methyl branch that's 1 carbon long, and it's on the 3rd carbon. And then there is an ethyl branch that's 2 carbons long, and that's on the 4th carbon. So when I go to draw my chain, it's going to be 1, 2, 3, 4, 5, 6, 7. And I'm going to make all single bonds. And I'm going to number the chain. And I'm going to number the chain from left to right because that's how my brain works. 3, 4, 5, 6, 7. And then I'm going to start adding my branches. So on my 3rd branch, I'm going to have, or my 3rd carbon, I'm going to have that 1 methyl branch. And on my 4th carbon, there's going to be the ethyl branch, which would look something like this. And then I have to go back and make sure that every carbon has 4 things stuck to it. So I'm going to add hydrogens like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. And that would be 4-ethyl 3-methyl heptane. The next one is 3,3,4 trimethyl hexane. That's a single bond. And hex tells me there's 6 carbons. The methyl tells me it's a 1 carbon long. The tri tells me that there's 3 of them. And the 4, the 3, and the 3 tell me their location. So when I go to draw this structure, I'm going to have 1, 2, 3, 4, 5, 6, and go 1, 2, 3, 4, 5 bonds, single bonds. I'm going to number my chain. 1, 2, 3, 4, 5, 6. And then I'm going to add my methyls. So in this case, there's a methyl on the 3rd and the 3rd. And so I'm going to add that. Little carbon here, little carbon there. And then there's going to be a methyl on the 4th. So that's going to look something like this. Little carbon there. Now I have to go back and add hydrogens so that every carbon that's present has 4 things attached to it. So that's going to look like this. And I'm going to do it in this condensed structure this time. because I know some of you draw it this way. Oh boy, I made a couple mistakes. Hopefully you caught them. So this should not be a 3. This should not be a 3. The rest of them are okay. So I'm going to go back to this, and this should be H. Should be an H2. I think I have it right. This should be an H2. Yeah, there it is. Yeah, that's right. So that's your 3,3,4 trimethylhexane. Now the last one we're going to do is a 4-propyl 2-octene. The ENE tells me there's a double bond. Oct tells me there's 8 carbons. The 2 in this case tells me the location of the double bond. Prop tells me it's a 3-carbon long branch, and the 4 tells me its location. So we're going to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to start with single bonds. And then I'm going to number my chain. 1, 2, 3, 4, 5, 6, 7, 8. And then I see that my double bond has to occur between my second and my third carbon. So I'm going to add that double bond right there. And then I'm going to add my propyl group on my 4th carbon. So that's going to look something like this. Oops. I'll make that a little bit bigger. Oops. Sorry about this. Little space. There it is. Okay. And then I'm going to bond them together. Okay. Now all I have to do is go back and add hydrogen so that every carbon has 3. So I'm going to do that by adding the hydrogen separately again, because some people really respond well to that. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. Okay. So that's how we would draw that structure. So that's 4-propyl 2-octene. Now, I want to talk about how these things will be graded. When you draw these structures, these are all going to be worth 2 points. And so what I'm going to do is I'm just going to take a half point off for every mistake that a student makes, up to 2 points. So like in the case of number 9, I'd be looking for 4 carbons, single bonds, and the correct number of hydrogens. At that point, you get at that one, you get I guess a free half point. But with number 10, I'm looking for 7 carbons, and I'm looking for all single bonds, and I'm looking for a methyl branch, and I'm looking for an ethyl branch, and I'm looking for the correct number of hydrogens, which is like 5 things. But I would stop after 4 so that a person would only get 2 points off. And now when we go up here for the naming, it's going to be the same thing with number 5. So these are all going to be 2 points again. And then when I name, so I'm going to do the same thing. I'm going to look for the correct number, the correct prefix, which would be half point. ENE ending for number 5, half point, correct ending, and then 2, the location, half point. So this one would be like 2 points, but you'd still get like half point credit no matter what. And then like for number 6, I'd be looking for the correct number of carbons, so pent, the correct identification of the triple bond, ine, the location of the triple bond, the branch type, which in this case is a methyl, and its location. So in this case, that's how I would grade all of these. So what I need you to do is, after you've gone through this, or after you've gone through your quiz with this answer key, just kind of give yourself an idea of what score you would get. And when we come together on Friday, we will take this quiz for real. So that sort of ends this video. If you have any other questions, let me know. and we will get to that again at some point or another. Otherwise, we're going to stop the video now, and we'll go from there. And how do I stop this? That's not what anybody wants to see. Stop the video. Stop the video. Stop the video. Stop recording. Oh no. Oh no.